We'll start our discussion with a very simple approximation algorithm, one for the minimum vertex cover problem. As input, we're given a graph, and we want to find the smallest set of vertices such that every edge has at least one end in this set. Recall that this problem is NP-complete. We reduced maximum independent set to it earlier on in the course. The approximation algorithm goes like this. We start with the empty set, and then, while there's still an edge that we haven't covered yet, we choose one of the edges from the graph arbitrarily, say these two here, and then we add both of these vertices to the set, like so. And then we go and repeat the process, picking an arbitrary edge from the remaining part of the graph, let's say these two here, and then removing all the edges incident on these two vertices, like so, and so on, picking this edge here, and so forth, removing all edges incident on those two. And we keep doing this until there aren't any edges left. This set C, which we've chosen, must be a cover. Looking back at the original graph, it's not too hard to see that this cover of 6 vertices is not a minimum one. Here is an optimal cover. It only has 3 vertices. So this Approx-VC algorithm returned a cover twice as large as the optimal cover. Fortunately, this is as bad as it gets. Given a graph G having a minimum vertex cover, say C star, the algorithm Approx-VC returns a cover C such that the ratio between the cover that it returns and the optimum one is at most 2. To prove this, it's useful to consider the set of edges chosen in this line here. We'll call this set M. We use M here because this set is a maximal matching. It pairs off vertices in such a way that no vertex is part of more than one pair. In other words, this set of edges must be vertex disjoint. That means that in order to cover just this set of vertices, any vertex cover must include at least one vertex from each of these. Therefore, the size of this set M is a lower bound on the size of the minimum vertex cover, C star. Since C star is a minimum cover, the set C chosen by the algorithm can only be larger. It is of size twice M, which is at most C star, as we already argued. Dividing through by C star here then gives the desired result.